All right, guys, we're going to look at reflections now. So, reflections are just a flip. So, we're going to flip over the x axis, we'll flip over the y axis. You also can flip over a vertical line, which would be x equals some sort of number, and then a horizontal line, which would be y equals some number. And then we can also reflect over the line y equals x. So, let's take a look here. We're going to reflect the rectangle ABCD over the x-axis, and then we're going to list the coordinates and look at that because that's going to help us with our rule. So we have point A. So to flip over whatever your line of reflection is, so A, we have the x-axis. This is going to be basically my line of reflection. The distance A is from that line will be the distance that it's going to be basically past that line. So A is 4 units above my reflection line. I'm going to make A prime. So the image of A is going to be 4 below. All right. So A prime is going to be at -4, 2 and -4. And then I'll do that for each of the other points. All right. So what you'll notice is that I am reflecting. So this could technically look like a shift. So if you don't see how the labeling is a big important thing here, because if not, it looks like it's just a shift down, especially with a rectangle like this. It's actually reflected. So it's really important that you pay attention to the label. So A didn't just shift down. A is not in the top left-hand corner anymore. It's actually in the bottom left-hand corner. So be very careful about the labeling of those. So what you'll notice basically is that the only thing that changes is that the y value becomes negative. So I went from 2, 4 to 2, -4. Same thing with B. B was at 8, +4. It went from to 8, -4. C went from 8, 1 to 8, -1. And then D went from 2, 1 to 2, -1. So all it did was make the y value the opposite sign. So if it were negative, changing it to a positive. All right, so let's take a look here. So we're going to reflect over the line x equals 1. So the line x equals 1 is a vertical line here at 1. So that's going to be my line of reflection. Here we go, a little bit better. So I'll reflect across each one. So again, very important that you pay attention to the labels because it could look like this was just a shift to the left, but when in fact it was a reflection. So when you're trying to identify these, looking at the actual labels would be a big important thing. And then here is a trickier one because you haven't seen one like this. This is going to reflect over the line y equals x. And so that line is right here. And so you're thinking, well, how in the world am I going to be able to do that? So what you're going to do is you're going to count how far your point is from that line still, but you're going to make a 90-degree turn and go the opposite direction to make your reflection point. So I'm going to go up 1, 2, 3, 4 to get to my line right here for x. Then I'm going to make a 90-degree turn to make my new point for x prime. So that's going to be reflected over. Same thing for y. So if I were to reflect over that line, so if I were to fold my piece of paper over that line, you can see that those points would be right on top of each other. So x and x prime and y prime and z prime. So you kind of have to, if you could just kind of tilt your paper just a little bit, it's still a reflection. So it's still a flip. It just looks a little bit different than what you're used to. So let's list these because this one is a big one that you want to pay kind of close attention to as far as when you're looking at these. So x prime is at 1, 5, but regular x is at 5, 1. It's interesting. Okay, let's look at y. Y prime is at 6, negative 4, but y, excuse me, that was regular y. And y prime is at negative 4, 6. And then z prime is at negative 2, 2. And regular z is at 2, negative 2. So hopefully you can see the pattern here that all we did was flip the x and the y. So when you are plotting these and you're going to reflect over the line y equals x, all you do is flip those two coordinates. So it becomes basically y, x. So let's take a look here. Here's our reflection rule. So a little bit it is going to look the same, but it's different from the transformation because the transformation is based on the information that you're given. And so you change some numbers in there, but the premise is still the same. Here, you're going to have to look at the line that you're reflecting over to see if that's going to help you. So we have xy is going to go to x, comma, negative y. So we just make the y value the opposite sign. So when I say negative, that doesn't mean that if it was negative, it stays negative. If it was negative, it then becomes positive. So we're just changing the sign of y. If we reflect over the y-axis, that is going to change the sign of x. Hopefully that makes sense because if I shift from one side of the x-axis to the other, then that's going to go from positive to negative and same thing, negative to positive. And then if I reflect over the line y equals x, then you are going to flip-flop the coordinates. And then if you reflect over the line y equals negative x, then you're going to flip the sign and flip the order. So it's a negative y, negative x. So those are your transformation rules and your for reflection. So again, it depends on where your line you're reflecting over, and then that's going to hold true to the rule. So you can derive the rule based on your coordinates that you're given, but it's kind of nice to be able to kind of check your work if you know these rules. So keep these rules really handy.